will give the stage to Lovelesh. Lovelesh, stage is yours. So big applaud because it's morning and we need more energy.
Thank you. Good morning, everyone. Thank you for being here early in the morning and attending to my session, which will be about self-healing tests. So we are going to talk about what self-healing test is, what we have in terms of technology on the market for self-healing, and how does it work. So let's start with, is it working? Good. Yeah, it's now working. Okay, so let's start with the age and, okay, let's talk a bit about me, so a quick introduction about me. So I'm Lovelesh, I'm from Mauritius. So Mauritius, actually the first question I get when I talk about Mauritius is where is this located? So it is just off coast of Madagascar, it's a long way from here. So I am by profession a software test engineer. I'm specialized in manual testing, in automation testing, performance testing. I'm learning about AI and security testing as well. I'm the CEO of a few companies in my country. I'm in ISTQB, so I'm the president of MSTQB, which is the Mauritian Software Testing Qualification Board. I founded that association, and then I got it registered with ISTQB. So now we are representing the local chapter of ISTQB in Mauritius. So that's a bit about me. So I'm passionate about testing. Okay, let's deep dive into the agenda. So first of all, we'll talk about the automation test engineer's nightmare. So what are the challenges that we have in the industry right now for test automation? And then what if tests could heal themselves? Okay, so if a test is failing, could heal itself so that negates the effect of having a false positive. A false positive is a test which is failing, but it should not fail. It should pass. And the reason for the failure is because either it is an infrastructure, you're not having an internet connection, or the test is outdated. It's not how it's supposed to work. So this is a false positive. And self-healing can help into tapping into this area where we'll limit the effect of false positive. Then what are the self-healing tests, the benefits of it, and some cautions, because if we use this technology for the first time, it's not going to work for the first time. You need some time to learn and some time for the machine as well to train, to start learning from your execution. So there will be some cautions that we need to be careful about. And how does it work? So we'll go a bit into the algorithm as well. There is quite some algorithm for self-healing, one of which is random forest. We'll go into random forest to give a view of how it works. Then I'll give an example of an open source self-healing framework that you could start using right away. And then we'll finish with questions and answers. Okay, so the nightmare of TAEs, test automation engineers. So automation is not something new. It has been there for decades. For example, I'm passionate about Selenium. So Selenium has been there for the last 20 years already. When it started, it was something very new. It was something quite creating a buzz. And even right now, it's something which is shaping our testing, the way that we do testing, the testing processes in a very different mode now. The industry has been quite acquainted and quite used to automation. And the demand for automation, the needs of the industry is evolving. One of the need would be the spice of randomness. Sometimes back when you write an automation test, you would hard code the test data. Now, what is expected is that when you run automation, each time the test data will be different, right? So I can give an example of why this is important, because I was testing an application for the French market. And as you know, the French language have some exquisite alphabets, right? So we were using test data like tester 1, tester 2, and so on, or English data that we are used to, someone's name, and so on, without these special character. So we tested it, went to production, and when in production, when a client was using special characters, was failing, was not able to save it in the format that they need. So a spice of randomness in terms of the test data, that is expected now from from an automation framework. Soft failure of test. So this is what I like to call the ripple effect of a failure. When we have a failure somewhere, that failure should be isolated in that test. It should not overflow to the other tests. For example, you get a pop-up, which is not expected. So if that pop-up is not handled, then the other subsequent test is going to fail for sure. So we need to have a certain strategy for keeping this failure into one segmented test case, and then move to the next test case execution afresh. So that's soft failure. And then recovery strategy. If ever there is something unexpected happening, the framework doesn't just stop working. So it will find a certain strategy to get around it and continue the test. So the framework should be robust in some way so that it can recover from some failure. Looping of tests. So that's something which is important as well. Mainly when you have to test the same test cases over and over again with multiple configuration, with multiple test data, with multiple precondition, this looping becomes important. And having the test case written once and able to loop with different configuration makes it easier for test maintenance on the long term. High configuration of test case, the same test case written once, is expected to be executed on multiple environment, on multiple operating system, on multiple browser, so it should be highly configurable. Then, this is something which is important, higher coverage, quicker. So the industry is expecting that they get a high coverage of tests in a quicker fashion. In a, let's say, one test case used to take, some coverage used to be achieved, 10% coverage used to take 3 months to be achieved. Now they expect it to be taking days. So high coverage, quicker. Extended verification check. When we talk about automation, we are not only talking about verification on the UI level. We are now expecting those verification to happen on the API level, on the database level, on the backend level, and so on. So having these extended verification is important in a framework, and definitely unattended test execution. If you're executing test cases, I would expect it to execute without any supervision. If I need to hire a test automation engineer to supervise the execution as well, it defeats the purpose of having an automated test. That person could just execute it manually. Reliable result, so we've limited false positive, right, in the result, so that you could use the result to really investigate defects rather than just spotting false positive. Then, easy access to real-time result. When we had a framework, when I conceived a framework initially for the company I was working for, there used to be an HTML file that was generated at the end of the execution. That was not enough for the developers. They wanted to have a real-time view of which test case is failing so that they could start investigating while the test is still happening. There's a framework called, the real-time dashboard that we use actually is Grafana. So that plugs in quite easily with Selenium, where you can have a real-time dashboard when execution is in progress, when there is a defect, you have the test case listed which is failing. So real-time access to result. Quicker test execution, so segmented execution or concurrent execution on different machines. This is also possible using the tool Selenium. So Selenium Grid allows you to have one hub machine connected to multiple nodes, segment your tests onto those different machines, and then have it executed. So if we have, in the company I was working, there was around 13 hours of tests that was being executed on one machine serially, right, one after the other. So we wanted to reduce that to have it overnight, to run these tests overnight. So then we set up the Selenium Grid where we had 4 machines executing those tests. It came to around 3 to 4 hours that we were able to complete the whole set of tests using Selenium Grid. Reliable metrics for the return on investment. There are metrics like the EMTE, equivalent manual test effort, and so on. But the real-time information that you get from these execution is more appropriate. So each time that you're running the test, the execution time is measured, what is the EMT is calculated automatically by the framework, so that at the end of the month or at the end of the quarter, you have a reliable figure about how much time you've saved by using this automation. So you can see all these needs are actually connected to some basic problem that we have. So the problem is around the test maintenance, unattended automated test execution, overflowing test failure, and there is one exception that most automation test engineer fear a lot is no such element exception. So when you're trying to find an element, it's not on the page because a certain maintenance has been done on the page, or there is a new build deployed, but you didn't maintain your test case. So now coming to the rescue, self-healing. So what if tests could heal themselves? There will be less maintenance for sure, right? So if there is a failure, a false positive, right, the test could detect that false positive, heal itself, and execute the test so that the false positive is negated. So there will be less test maintenance. The test can run without the need of a human supervision. This is where it becomes really unattended on a reliable level. And then test failure can be isolated and contained. So we avoid the ripple effect. This is something that I was struggling as a test automation engineer in the company, because my test was, when there was a failure, that failure would overflow onto the other tests that would follow. So then I tried with self-healing. So what are self-healing tests? So first thing, a self-healing test is a framework that actually hosts the test cases that allow the test to heal themselves or to repair themselves. For example, when a web element is not found, so on automation level, we use locators, right? So we use locators to find element that we want to interact. For example, a text box or a button to click on. So if the locator of that element is not found, the framework will try to find an alternative locator to feed into the automation engine for it to repair, right? So automatic reparation of the test cases. It uses machine learning, so this is where we need to be careful. If you run only 3 to 4 times the test and you try to apply the self-healing, will not be reliable. You will get a lot of other locators that will be supplied to your framework, where defects could then be missed. So we'll have that false negative. So we'll miss defect from our test. So we have to be careful with this part. We need to train the machine. We need to take our time to train the machine. Then most of the self-healing framework are probability-driven. They are based on some ML model, machine learning model. For example, there is one Bayes theorem on probability, so Bayesian model for machine learning. This is one algorithm that we could use for self-healing. There are others, like random forest as well. So it can be based on probability, and it can support multiple technology. For example, the technology I'm going to talk about is supporting robot frameworks, selenium, selenide, etc. Okay, so these are about the self-healing test. So benefits of it, definitely less time wasted in maintenance. Why is maintenance such a pain for a test automation engineer? I like to use this analogy for comparing coverage and maintenance. So as a test automation engineer, if I take someone, okay, who is walking with a knapsack, right, on his back, and the distance that he's walking represents the coverage, and the weight of the knapsack represents the test maintenance. As I'm walking a certain distance, the knapsack is getting heavier. What does it mean? So as I am increasing the coverage, it means that I'm having more tests, right? Having more tests means more maintenance, right? How do we solve this? So as I'm walking, the bags get heavier. So what I need is more people to help me to carry that bag. So I hire more people, right? But this is a spiral, because I'm going to get a certain additional coverage, but the knapsack is going to get heavier. So there will be more test maintenance on the long term. So we get into this spiral where we need to continue hiring people to continue this test maintenance, right? So this is where self-healing actually helps to reduce the test maintenance effort. So less time wasted in maintaining automated tests, more resilient automated test. And there is a study, and this is something that we were able to apply to the company as well, to the company I was working. Tutorial Point actually made a study in 2022. So some company were using around 52% of their resources to do test maintenance. They were able to reduce it to 14%. So what does it mean? There are some tests, if there is no self-healing framework behind, it's going to fail, right? So with self-healing, they are no longer maintaining the test. The XPath, the locators, the CSS selector, the IDs, and so on are not maintained. They rely on the framework to actually find a better locator for it to work. So they are able to reduce the effort from 52 to 14%. And then we were able to achieve higher coverage easier, because then the time saved from test maintenance, we are able to invest it on writing new test cases. So still in our framework or in our test suite, we still have tests with outdated locators, but we rely on the framework, on the self-healing framework, to just correct it on the go. Right? So this is some figures from my project. So for a project having a sequential automated test execution time of 13 hours, that would mean around 6.5 hours of that period is invested into test maintenance. And with self-healing framework, we are able to reduce that to 2 hours. So then 4 hours, 4.5 hours is then injected into writing new test cases. Right, so that's the benefit. Now, some caution. So we have to be very careful to beware of the false negative. So for self-healing to be really effective, the training period should not be neglected. We cannot expect the self-healing to start giving a return on investment during weeks. For us, it took really around 2 months, 3 months to get the self-healing to start really understand what we were doing in terms of test, and to also as well provide locators that were able to work on the platform. So we have to be careful about the false negative. There is a log which is created by most self-healing framework, so we have to review those logs. We have to make sure that whatever is being healed by the framework is correct. They're not healing something which is supposed to be a defect. So this review is important. We still need to inject some maintenance effort. Not everything can be healed, right? Sometimes it is probabilistic based, so not everything could be healed. So we still need to maintain a certain minimum periodic test maintenance. And we have to be careful of not getting into the spiral of pesticide paradox. So pesticide paradox is about tests wearing out. So if you write a test now, right, and you don't add any additional tests, or you don't maintain it over a long period, this test will no longer be effective because it will not find any new defect, right? That's one of the testing principles. So it's quite easy for us to get into the pesticide paradox, because the healing, the test maintenance, we just rely on the machine to do it, and we just say, okay, fine, the test is working, we don't need to add any additional tests, or we don't need to maintain the test. And then we have to keep an eye on the versioning of the self-healing technology. So sometimes the machine learning, the model behind that we have in these technology updating, and they are getting better and better at healing locators. So versioning is something that we have to keep an eye always to use the latest one. We've saw the difference in terms of efficiency of healing from the previous version to the new version in the framework that I was using. So these are some cautions that we have to be careful about. Okay. Now, the self-healing framework itself. So there are 2 phases. There is the learning phase and then the healing phase. The learning phase, so it's about the test script is feeding the test step into the automation test executor. For example, if I take Selenium, that would be the Selenium engine. And then the Selenium engine is executed on the SUT, the system under test, right? So if we don't have a self-healing framework behind, this will be the straight way of execution: the test script, the execution engine, and the SUT. If we have a self-healing framework, from the executor, there will be a connection to the self-healing framework. And then the machine knowledge will be stored in the database inside the framework. Okay? So that's one part where it is learning. For each execution that you do, it's learning about where you're trying to click, what are the alternative locators that could be used, what are the properties, what are changing in the application, and so on. So that's the learning phase. And this is where you need to invest a lot of time to make sure that you have the right machine knowledge in your self-healing framework. So once it has learned, right, then we'll start healing. So the healing phase now. So the test script feeding test step into the engine, the automation engine, going to the SUT, and the locator is not found over there. So we'll give a feedback to the self-healing framework. We use the testing knowledge that they have, provide a certain alternative locator or heal locator to the automation engine, and that heal locator will be used to execute the test. So that's the healing phase. Right. So for it to work again, the machine knowledge is important, and the connection between the test automation executor. So if you're using asynchronous execution, this is where you need to be careful. You might need to, let's say, block a thread so that the healing can be done, and then continue that thread in terms of execution. So multi-threading programming, if you're using test automation framework with multi-threaded programming, so you need to pause some thread for it to heal, and then continue the execution. Okay. Now coming back to the machine learning part. So self-healing framework has, in the industry, they tried multiple algorithms. They tried multiple algorithms for the self-healing framework. There is the reasoning techniques, which are really clever programming, like having selection construct for example, if, case, try, catch, and so on, so that you could limit the ripple effect. You could give a certain intelligence to the programming so that the machine could execute the test correctly. So in reason techniques, we have the rule engine, which is essentially the if-else part. The deductive classifier, so what it does is you have a certain rule that is already set, all right? You use the rule that is already set, and you have on top of that a lot of cases. And then it deduces in which case it should go. You have the case-based reasoning and procedural reasoning. This is the reasoning techniques. It's quite clever programming. It's towards clever programming. And then you have the machine learning algorithm, where you have neural network, decision tree, random forest, Bayesian model, and linear regression. So I've experimented with framework using Bayesian model, using random forest, using linear regression, and the best one that actually works is random forest algorithm. They are able to give, with a 95% confidence, the heal locator, right? The Bayesian model is based on a lot of probabilities, and sometimes you don't understand how it came to that locator. You don't have a mapping. But with the random forest, each time you execute it, the aggregation is more and more refined. So with the proper training, you are able to get the right output out of it. So let's concentrate on the random forest. So how does it work? So you have a data set, and you have multiple trees. So given that it's multiple trees, that's why it's called random forest. It's multiple trees becomes forest. Okay. So each time you are executing your test, it creates another decision tree. And when there is a locator which is not found through your test, it goes through that random forest. For individual trees, it gets a certain result. And then it is aggregated. All these trees are aggregated together, and then you get a final result. So the final result actually is an index or a probability of how likely the heal locator is to be the correct one. So if you see it into action now, there is one example for a self-healing framework, which is Helenium. So I found this one is quite easy to use because it's plugged in with Selenium quite easily, quite seamlessly. So it's open source, right? But if you want to support additional support, then the support is paid, definitely. It works with Java Selenium, with Selenoid, with Robot Framework, with the WebDriver, Cucumber, Serenity, and Selenite. And they are developing other plugins, adapters for other automation framework. And the adapter will be available. Actually, right now, I think it's already published. They have a beta version on the website. So for RPM-based test automation solution. So Selenium, how does it work? The learning and the healing phase. First of all, you have to implement this dependency. If you are using Java Maven framework, this is why I tried with this version. And this is last month. It was the latest version that was deployed last month, so on Selenium. The example that I'm giving over here is it's working only for Java in Maven framework, right? So let's see the Selenium framework in action. So it's trying to find an element. It is found because it's looking for BTN, and it is BTN over there. Once the locator is successful, it will store it onto the framework, the healing framework. This is a Docker framework, containerized Docker framework. And now the application changed, but the test didn't change. So the element is not found. If it is without the framework, it will fail over here. But with the self-healing framework, we'll go on to the tree comparing. It will give you alternative locators with probability. You can see the stars over there. This is the probability, the weight that you get, or the aggregated sum that you get from all the decision tree in the random forest algorithm. So in this case, it's able to heal the locator and click on the button. So what I'm saying over here is the application is evolving, but your locators on your test then doesn't require maintenance, right? And we've executed tests without these updated locators for months without any failure. And for us to achieve that again, we need to train the machine correctly because it's relying on this Docker container in terms of repository for the knowledge. If this is not plenished correctly, then this whole framework will not work. I've heard a lot of my friends in test automation engineering trying this, and they say that it doesn't work. It's giving a heal locator which is not working on the application. We are missing out bugs and so on. This is all because the training investment was not enough. So each time when you're running the test and it's passing, you know it's passing, you have to run it over and over again. What we did was to run it overnight over the Selenium grid, 4 machines running it concurrently, to plenish this database of locators, of self-healing framework, so that we could use it after months. We could use it correctly and get the heal locator. So this is Selenium. Right. So that's about the self-healing. Questions? OK, we have some questions. We are good on time, right? Yeah, OK. Please, not a hard one.
No, that will be an easy one. Thank you, Lovelesh. If I understand correctly, you look for an alternative locator. Will your test script be adapted based on the new locator? So I didn't saw that step, that you changed the original automated script. OK, so you could do that because there is a log which is created with the self-healing framework. There is a log which is created. Each time a locator is healed, another separate text file is created. So you could just copy-paste that, or you could just avoid it, right? You just rely on the framework to heal it. And this is where you save time. So your test, the execution of the, I would say the locators that you are having on your test is not updated, but you need to maintain the step of your test. If ever there is an additional verification point that you could add, you should add it, but not necessarily go into the locators. If it is healing, and it takes milliseconds to do that. So it's not adding any, let's say, too much load in terms of execution and so on. So we did maintain some test cases that we deem critical to
to have the updated locators. For those test cases that we said was priority 2, we just left it like this, and we expected the Selenium framework just to heal it. So this is where we save a bit of time. Does that answer the question? OK, perfect. Sorry? Trying to heal. So it will take, in terms of milliseconds, you could configure a loop inside your framework now. You say, you could configure the framework to give you 10 heal locators. You try the first 3 out of the 10. So it depends on the loop, but this list is created within milliseconds. So for each heal locator. Yeah. Yes?
I will give you 2 scenarios of changes. So one is scenario A is XPath change, and scenario B is name change, like button. Which scenario is more likely to be healed by framework?
OK. Well, so if you use XPath, the XPath, you could construct an XPath locator like // then star, and then you have in square bracket @name contains or something, right? You could have this attribute inside the XPath itself. If you're using XPath, because what I tried was on XPath and an ID, I was having the test was written in XPath and then executed. Then I've input, in the test case, I had injected a wrong XPath and to see whether it heals. And when it heals, it's not necessary that it gives you an XPath. It could give you the corresponding ID based on the new one. So both could work. It could give you from an XPath to an ID, and if you input an ID, it could give you an XPath. And if you're writing all your tests in XPath or ID, it will give you the corresponding heal locator in that case. So it is not dependent on which type of locator you use. It works even for CSS selector. So you could configure the framework. You could configure it to give you always an XPath, but if you leave it open, it will give you any locator that will work on the application. Does that answer the question? Yeah.
Well, I'm asking more about probability. So would you bet more for A or for B?
For let's say, the best practice that I've learned, I would go really for XPath. XPath is much more extensible because you have XPath access that you could use. You have XPath functions that you could use. I'll just give you one example. If you use an XPath expression, for example, of a text box for password, right? The name of the field is password, is pass, let's say, PASS, right? You write an XPath // and then in the predicate, in the square bracket, contains pass. If tomorrow it changes to pass1, pass2, or even password field, it will still be valid. So it is more robust in this case by combining XPath functions, access, it makes the locator more robust. And then relying on this framework, with robust framework, gave you, with the robust XPath, gave you a better healed locator then. Does it answer your question? OK, perfect. This question there, Daniel.
Okay, so 2 questions. One of the things, so something that I understand the application try to find some kind of substitutions. So can you have a possibility to set up some kind of scoring? Yeah, for example, that the selector might be 80%, 90%, and that means that is fine enough to go ahead.
Yes.
And the second question is about the main purpose. Main purpose is to better maintain such elements that we can treat as a substitution and something that change and we need to change in our framework, or to move forward with our test, to not have a blocker. When we find some kind of good element, we can go forward and move tester further.
OK. So for your first question, in terms of probability, what you get actually when the quick comparison gives you a list of heal locators, you get a percentage with it. So that you could now on your framework access those percentage, and you say only take the 95 or above. So that's the first thing that you could do. It's not always going to do the first one. Okay? If by default you're using without any configuration, then it is going to take the first one. But you have this configuration where you always could specify above how what the confidence level minimum you need. Above that, it will take the locators. That's the first. Does that answer the first one? Good. The second question was the purpose of it, the end, what's the end aim of having this kind of framework. So this was a heavy discussion that we have inside our team. We said, okay, we will not be maintaining all the tests. Once we get the report for the heel locators and we see it's passing, we will not maintain all the tests. We had to break our tests in terms of P1, P2, and P3. So that will be priority one. That will be the MVP part, the minimal viable product of our system that we are testing. Any test on the MVP will be P1. Then we have P2. That will be where we can have a workaround. These kind of, if ever there is a failure in these tests, it will be of, let's say, less severity. So the less severity and the least one, we didn't maintain it. We took only the P1 and we had to make sure that these tests are always up to date and are always having the latest locator. So this is where we were able to reduce the time of maintenance. So we saved that time, and then we injected it into writing new test cases that was of higher severity if ever there was failure. Because the application is always evolving. So you need to write new tests, but you need to find time to write new tests without actually just exponentially grow your test team as well. So that was the purpose, and we were successful into that. Yeah. Okay, we have a few questions. Over there.
I have a rather maybe technical question. In random forest, when you have these trees, in each node you have a single parameter which, when the tree learns, it selects the parameter which splits the data set in the best way according to some entropy rule and whatever. So my question is, because I understand that in the leaves we have locators with some probabilities or whatever, but what are the parameters that are used to split the data set?
Okay, so in the tree, for each edge that we have, so one node connecting to the other, we have a weight of it. So this is the learning part where the weight increases each time it is going through that part of the tree. So let's take the green node at the top. It's keeping the probability of this being the item clicking on it. So just like a DOM, the document object model that you have on a web page, it's a tree. You have the HTML, you have the body, the head, and inside the body and the head you have other items. So each time you're traversing this tree, it's keeping the probability and organizing this probability in terms of a tree structure. And this is what you're using actually to come down to the locator that is going to heal. Does it answer your question? Okay, perfect. Yes, please.
Hi, thank you for the presentation, really helps.
Welcome.
Can you give any example when test was healed but should not be healed because it hides a bug under the hood? Any example?
Okay. Okay, so for that one, I'll take, let's say, the login page. The login page. So in the login page, there is a verification that is done to enter the password, and the password should be input masked, right? So there is a property there that we validate in the next path that select the text box and verify that the element has the input mask over there. And this is a real situation that we had. We tried it in different scenarios. It finds the text box, but the XPath that was then healed didn't have this property of input masked. So it was able to continue with the test, but without checking whether the password that you enter is masked. You get the point? So when you type the password, it should be appearing as asterisks on the text box. So we removed that property, and we were checking whether our automation framework could deal with that. There was a verification in the original XPath, but when it healed, it didn't check that part. So this is one example of a false negative. It was supposed to capture this defect, but then it didn't. And this is where you need to invest the time. You need to make sure that this step is then separate and not done in an XPath, that you check whether this element and it has a property input mask enabled. So you have to make sure that this is done in a separate step, and the first one passes, and then the second one, it then checks it separately, not within one XPath. So using the log that was created, we were able to drill down how to write the test cases in a better way so that we can avoid this kind of false negative. it answers the question. Right, perfect. Yes, Daniel.
Hi, Lovelesh. Thanks for the presentation. I just want to ask, isn't this just a patch for low testability of systems? Because when you have proper design of locators, maybe there is a work on maintenance, but not much.
Yeah.
And also, when you have new tests, I understood you have to basically train, or when you have new features in the system and you write tests, so you have to train the system for the new parts of the UI which were not covered. So you are not constantly maintaining, but constantly letting system to learn that.
Yeah. So when you have a new part, let's take with the second question first. So when you have a new part of the system, this is where the healing will be unreliable, right? Because it needs to continuously learn the new part of the system as well. So this is why you need to have the classification of the test cases, right? So if it is a new part, it will be always P1. So whatever is being healed over there, we need to investigate deeper into that. So that's the first thing. And the second thing, the first question that you asked was about if we have the best practice of writing locators in a way, shouldn't this then be just reduced in that case? We should not be having this kind of framework then in place. That's true. But the gain actually comes when you have the best practices applied, the application changes, and still you have a heal locator. So one type where you can save a lot of time is just using the look that was created. Instead of you going into that web page, inspecting for that text box, the Healing framework gives you the locator directly. You just need to copy paste as well then. So that is, in any case, a help for you to save some time. But if you have the best practice and the locator, it is more effective anyway. Because then the healing is expected to be even less, and then you are able to just copy paste those from the text file into the test case. Sorry? You have to spend time yes. Okay, so the training as well. The training was done, given that it's an automation framework, we just run the same test over and over again overnight, right? So we did that for months. And after months, we were able to reduce really 13 hours, for one project I'm saying, 13 hours of execution time from 6 hours of maintenance to 2 hours. Yeah, so that was a bit the gain that we had.
Okay, thank you very much. Time for questions is up. So let's applaud and thank Lovelesh
Thank
for
you
the
very much.
presentation.
Thank you.